Hi, welcome to Agastya Whiteboard Docker session series. This is Anju BIkka. The agenda for today's session is Docker containers. So we'll elaborate more on Docker containers in the session. Let's start a container overview. As we discussed in the previous sessions, container is an running instance of an image, of a Docker image. Or we can consider container as a isolated virtualized environment. So in this fashion we can define image is an instance, running instance, isolated virtualized environment. These are very high level definitions. Let's elaborate more from the ground level. When we have a program, for instance, when we have a program hello Docker is a Java program. The program name is hello Docker. This is the program. Once we have that program, we are going to run that program by using the command java hello docker. When we are running this program, it is going to start executing. Then that program is called a process. So the main difference between the program and the process is nothing but a program which is under execution. By using that same program, we can start any number of processes like P1, P2, P3, like that. Any number of processes we can start by using the same program. But these processes, very important to note, not isolated process. These processes, they are going to share the same resources on which these processes are created. This is the one point we need to note. And again, the process is not going to be executed forever. They're going to have one starting point that is called entry point, entry and exit. They are going to live for a particular period of time. They will start at a particular point and they will end at a particular point. They execute. This is about the process. From program, we are going to start the process as a program here when we have a Java program or any program. By using that program, we are going to start a process. Process is nothing but a program under execution. Now we can relate this one to a Docker images. Now when we have a Docker image, then by using the Docker image, we are going to start container. Means container is nothing but a running instance of an image. Like a process is nothing but a running program which is under running, executing. The same way, container is a running instance of image. Running instance. This is the first one. The second one, when we define a Java program, the entry point looks like this. The entry point is a main. They write like this. So in the Java program, the execution starts at the point of main and it executes and it terminates. In the same way, and we saying image where the entry point is lying. What is the lifespan of a container? We will elaborate more on this one later. That is the one. And the second difference is container is a running instance, but it is isolated. So when we are using one image, when we start container image 1, when we have image, when we are starting container 1, container 2, container 3, all these containers are isolated. For example, when we have a program, program, when we are starting process P1, P2, P3, these are not isolated. But these containers are isolated from each other and also isolated from all other processes in the system. This is the main important point to note. Now we can see here a Docker is a definition we already discussed. Docker container is a virtualized runtime environment. Also we can consider as a instance of image. By default, it is isolated from other containers on its host system. Now from Docker file, we build Docker image. From Docker image, we create containers by using run command. Again, we are going to create images by using containers. This part we didn't discuss so far. We will elaborate more in the upcoming sessions. Now, the entry point. So when we say Docker is a running instance, what about the entry point? Is nothing but the entry point is defined in the Docker file by using an instruction called cmd or by using an instruction called entry point. We will elaborate what is the difference between cmd and entry points in the upcoming sessions. When we are creating a container from a Docker image, for instance, we discussed about Docker file. So the Docker file is prepared by using instructions followed by any arguments to that instruction. So for each, how many, like we do have four instructions. When we are preparing, when we build an image by using the Docker file, it is made up of 4 layers. The important point is these are read-only layers. Means we can't modify these layers. We can't write anything on these layers. So this is the image of a Docker. So what happens when we are creating a container from this image? Like when we are creating container C1, when we are creating like more than one container C2 and C3. If these containers want to do some computation, if they want to store some data, where they are going to store? Because these are read-only layers, they can read. All these containers can read these layers, but they can't modify these layers. Let's see here. So this is the image. When this image, by using this image, we created 4 containers. 1, 2, 3, 4. When we're creating a container, each container, when we are creating a container, one thin layer is created for each container. That is a read and a write layer. This layer is completely isolated from the rest of the containers. This read and write layer of container 2 is not same as container 1, not same as container 3, not same as container 4. Means all the containers share the same image layers. They share, but each and every container has its own writable layer. Because these image layers are read-only, the beauty of this architecture is it is saving a lot of space because of they share this same common layers. But the question is going to arise. For example, if the container 1 want to modify something in this layer, if the container 3 want to modify in this layer, how they modify? They can't modify. What happens? This is what we are going to discuss, called copy on write mechanism. For instance, if the container 1 want to modify a file F1, container 3 want to modify a file F3. What happens is this F1 is copied into the read-write layer of container 1. F1, the copy of F1 is prepared here, and the copy of F3 is prepared here. So the container is going to modify F1, not here, it is going to modify here, and the container 3 is going to modify F3 here. Means they are not modifying on the original copy, they are modifying on the copy of the file. So this is what called copy on write strategy. When a file in the base image is modified, the copy of the file is going to be done in the read-write layer and they modified on the copy. Let's make our hands dirty by doing some practical lab on Docker containers. For the commands, you can refer in the link displayed here, https://docs.docker.com engine reference command line container. You can see more commands. Now, to start a container, there are multiple ways to start a container. First, we have to pull that image if the image is not available locally. Then once the image is pulled, then you have to create the container from that image. Then you have to start. So when we are doing, see here, the Docker, this is the base image. If it is container related, you can see container is followed. If it is image related, then you can see image, Docker image. So that is the reason. For all the commands, Docker is the base command, followed by on which we are working. On containers means container create. From which image you want to create a container image, and the options. These are few options. For more options, you can refer the Docker documentation. Once the container is created, so this container, while creating, it pulls the image. If the image is not available locally, it pulls the image. Then once the image is pulled, it creates the container. But it's not going to start that container. Then you have to start in this fashion, Docker container, and followed by start, which container ID or container name we have to pass. Then few options, attach and interactive mode. Then another fashion is directly doing a run command. When we are doing the run command, what it does, first it checks for the image. If the image is not available, it pulls the image. After pulling that image, then it creates the container. Then after that, it starts the container. Means it does three: pulling the image first from the registry, from private or public Docker Hub registry, then based on your configurations. Then once the image is pulled, it creates the container. Then container is going to be started by doing one command called Docker container run. Let's start running HTTPD Apache HTTPD server. So open the hub.docker.com, then you can search for HTTPD. Like here, if we go to hub.docker.com, then once you're opening this one, then go for HTTPD. Then you can see here HTTPD. Then is a Apache HTTP project. If we click on that, then now we can see the tags. In order to pull that image, now you can use the Docker pull HTTPD to create a container. You can do Docker create the image name. So this is the image. So what we are going to do, so Docker run, and we are going to say the name of the container is my HTTPD, followed by the image name. So here docker is the base command, followed by, if it is container related, you have to remember docker is the base command. If it is container related, container is the sub command, then followed by run. And once the container is created, what the name we want to give to that container is my httpd, followed by the image name. Image name is httpd. Click enter. So it is trying to find the image locally. As we discussed earlier, if we don't specify the tag name, it's going to take the latest. If you don't want the latest tag, you have to manually specify colon the tag name. Now it is unable to find the image locally. Now it's pulling. That's what we discussed. The run is like when we're doing the run, it pulls fast, followed by it creates container and it starts the container. See, it is the container is started. This is the way we can start the container. Once the container is started, you can check what are the containers are running. Some like a docker is the base command, container is the sub command, ls. Now you can see all these containers are running. The one we started, this is the container. This is a container ID. The image is httpd and it is created a minute ago. So the names of the container is my httpd. If you don't want to run a container, just you want to create a container, then we have to do this fashion as we discussed, docker container create, and you can give the name is my httpd2. This is the name of the container, and the image name httpd. Here what the create command does, if it checks for the image, if the image is not available, it posts the image and it creates the container, but is not going to start. If you click enter, the image is already available, it's not pulling, it is just creating container. Now you can check docker container is the command ls list. So it is listing. Now you can see here, this is the first one. It is up httpd. We will say the command, it is up for 4 minutes. The one which we created, we can list all the, see when we're doing here, it is only listing all the running containers. If you want to check all the created and stopped all the containers, -a option, then whenever you are doing that -a option, now you can scroll, there are too many containers are running. Now you can see here, this is the container we just created, but it is not, the status is created, is not running. It is running here. So once this container is running, now you can start this container. So if you want to start this container, either you can use container ID or container name. Now you can say docker container start, followed by container ID or container name. Now you can say it is running. Now docker container ls -a means all the containers. If it is stopped, it is created, running, everything, you can get -a. If ls means it is going to be only running containers. Now you can see it is up. Now this container is running. So this is the option. So to pull, pull, create, start. All these are embedded in the run command. If you do the run command, it does all the three. Now we need to access HTTPD running in a container. Let's check those container IDs again, once again, docker container ls. If we see now, we do have two HTTPDs are running. One is with this container ID and another is with this one. You can copy this container ID. Now we need to inspect. There is another command called inspect to check the container. So docker is the base command, container is the sub command, inspect followed by docker ID. When we click this one, inspect, now is a network. So there is a very big JSON file. We'll go through all the elements in the coming sessions. Now we are more interested in the networks. Again, we are going to do a separate session for network storage, Docker storage and Docker network. Only we are going to discuss very briefly on the network. Now we'll see network. Here is this is the gateway, IP address 172.17.03 and MAC address here, and here the port. What is this network is? Each Docker container is associated with a private network. So this network IPs are not accessible outside the container. Only to access these IPs, this means 172.17.03, you have to enter into the container, then you have to access. You can't access outside of this one. So while entering into the container, then on this IP and this port 80, we are able to access the application. But outside we can't access because these IPs are private within this container space. Then how to access the applications which are running within the container? First, access these applications by entering into the container. So for this one, we are going to do a command called docker container exec. We will elaborate on this command later. IT interactive terminal container ID, which we copied, then slash the command we are doing bash command, bin bash. When we are entering here, then we are entered into the container. Here now, if we do curl of if the curl is not available, what you need to do, you need to check what is the Linux distribution by using cat etc *-release. If by doing this one, you can check this is Debian and version 10, and this is the home URL, support URL, and now we need to we have to already is in the root apt-get update. Just update. Once it's updated, then apt-get install curl. Then curl is installed. Now we are going to do curl http 172 dot, what is that one? 17.0.3 by default. If you don't specify the port, is by default is the port 80. So the port is 80, so no need to specify like this. This is by default. So when you enter, so it works. So now we're able to access the application. If we exit from here, now we are on the host. If we do curl of this one, now we are not able to access that application. So to access that application from the host or outside, so this is the concept of port binding. As we mentioned earlier, we will do a separate session for Docker networking. We are discussing here, we are focusing on how to access the application, and we'll discuss all the networking part of the Docker later. So now here, to access, this is our container, this is our HTTPD container. So this container, within this container, now the port 80 is exposed. So to access this port, then we need to bind that port to the host port. The host port is like the host port 999. We are going to bind to the container port 80. Then from outside anyone is calling is not container IP, the host IP. So anyone is going to call host IP colon the port. Port means 999 from host IP. Now that is going to be forwarded to the container on the port 80. So in this fashion we are going to access the application. Let's start the container by, so we started that container previously, but we didn't binded that port to the host port. Now let's go and bind that port so that we can access the HTTPD from outside. Let's remove those containers which we created. We need to check the IDs of those containers, Docker container ls. So those IDs are this one. So then we're gonna do Docker container remove. Then this is the first ID followed by second ID. Then those two containers are going to be removed. So error response, you cannot remove running container. First we have to stop that one, then after that we have to remove. Then let's go and stop it. Those two containers, those are stopped. Now you can remove those two containers. So now we already discussed the stop command as well. To stop the containers, Docker container stop followed by container IDs. Then once the containers are stopped, then you can remove as it is prompted. You can't remove running containers, stop the containers before attempting to remove, or we can do forcibly removal, but that is not suggestible. Always go to stop the containers and remove the containers. Now the port binding, Docker container run. So hyphen name my HTTPD. Then after that, so to do that port binding, option is P. Then first we need to do the host to port followed by the container port. Then how to check that container? I will show it to you that in a Docker file there is an instruction called expose. So I will show it to that. So first is the host port followed by the Docker port HTTPD. Now if I enter this, now is running. Now you can open, now we can do, we can access that HTTP. Now we need to check that container ID here, Docker container ls. So if we check this container ID, this is the container ID. So we have to inspect now this container is running. Now we can do ccurl and Docker host is the local host followed by 999. Now we can access the app outside. Again we can open the browser. So this is the way. So to access any app which is running within that container, so we have to bind that one to a host port. So by using host IP followed by host port, we can access that application. Again, we will elaborate more detailedly in a separate session, Docker networking. To check the Docker container port, if we go to that image, Docker image command, okay, if we check that history of HTTPD, or you can go to that file, or you can go to the Docker Hub. Now you can see here it is exposed to 80. This is one fashion. Another way you can go to the repository and check for that HTTPD image. In this image, if you go to the tag, and you can check on tag here, you can see the image layers. So this is the image layer exposed to 80. So when we're running this one, so this is the container port number 80. Let's discuss more on Docker commands. Let's see how many commands are there. If we see Docker container -help, you can check these. So now attach, commit, and cp. So let's discuss attach, commit, and cp means copy files. Create, we already discussed. What is attach means? Attach means attach a local standard input or output and error streams to the running container. When we are running a container, so Docker container, and the name we're gonna give my HTTPD2. We already have the name HTTPD. Now the image is HTTPD. When we are running this one, it is running not in a detached mode, in the attached mode. When we run like this, so when we run name, and we have to use the command run. So when we run this one, so it is running in the attached mode. You can see the logs are here. So if you want to run this one in the detached mode, now I'm going to run one more container. In the detached mode, you can do -d, detached mode. Now we can enter. Immediately you can see this is the container ID. So you don't see anything. So now if I want to attach this one, now we're going to do Docker container attach, and you're going to copy this ID, is going to be attached. Now when it is attached, when we are accessing the application, now you can see the logs are scrolling here. To do that, so what we need to do, because we haven't binded this one, so that is the reason we can't see the loggings. To access those loggings, again you have to open another command prompt, trying to access within the container, because we haven't binded, we haven't done the port binding. So we can do Docker container exec -it interactive terminal. This is the container ID, and if we do bin bash, now we need to inspect the IP of the container. So first we have to exit here to inspect Docker container inspect container ID. Now we can see what is the IP of this one. 170. The range always starts with 172, 172, 174. So now we're going to enter here. Then we can do curl 172. So 172 17034. When we enter, see curl is not found. We have to update this Debian. So once it's updated, we have to install the curl. It is updating. So now apt get install curl. Now curl is installed. Now curl HTTP 172.17.0.4. When you see here, when you are accessing, immediately you can see the logging here. So that is the way we need to attach. So when we want to run in the detached mode, you can do -d. After once you detached mode, if you want to do the attach, we have to attach. Now the commit. What is a commit? What is a commit means? Now see, the commit means whenever we created an image, let's do the whiteboard explanation. Whenever we created a container, this is the host. Whenever we created a container, after creating a container, if we do any updates or installations within that container, with these all the changes, if you want to do an image, the reason is, if you want to create, so once we created a container, then we installed software and we updated. If you want to create a new container, we have to again create the container again. We have to go for installations and updates. We have to repeat the same steps. Instead of doing that, with these updates and installations, if we create the image, with this image, if we create the containers, then you can see your installations and updates within the new container. That is the reason. So previously we discussed from Docker file. So we created the image. From image we created the container. So but the problem is, whenever we update the container, if we want those changes to be available for the other containers, so from this container we are creating a new image by using a command called commit. Now we're going to create the image by using these container updates. So Docker container commit, and this is the container ID, then followed by the image name. We are going to give my httpd-v1, the tag. Otherwise it's going to be as the latest. If we don't specify the tag, it's going to be a latest. So if we enter, so now a new image is created. Now we can check for that image. This is the idea of that. So we can check for Docker. So to list the container, Docker container ls. To list the images, Docker image ls. If you see this one, so this is the image we created, my httpd version v1. So with this one, if we start that container, so Docker container run in the detached mode -d, and you can do -d, and even do -p as well with 777:80 and my httpd. So when we run this one, so we have to do -v1. So it's not a latest, we have to do the tag v1. So now the container is created. Now if we can enter into that container, we can see update is done, curl is already installed, Docker container exec-it interactive terminal, and this is the container ID. And if we go for bin bash, so if we enter the curl, so curl is available. So all the updates you made are available within this container. So that is the way we are going to create image with the modifications made to the container, with installations, modifications, anything, so that when we're creating a new image with that container, so from any containers are created with that new image, so you can see all your changes you made to that existing container. Let's discuss other commands. So Docker container -help. So far we discussed attached and a commit. Commit means to create a new image from container changes, and copy. So how to copy from local means the Docker host to container, container to the host. So we're going to use this command. Let's start this one. So Docker container ls. Let's see the container. So if you see the container, this one httpd, and if we go and execute that, so Docker container exec-it, this is a container ID, so bin bash. So once we are in this container, so this is the container file system. If I want to copy some files in this location, for example, if I want to copy some file in the conf, in the location, so this is the location of conf. So if I see ls, so the only extra httpd conf magic and mime, so these are there. So if I want to copy some file from local system, let's go and open the local system and create one file. So this is the my local system. In so in C demo, I'm creating a text file. Text file is docker copy command demo. So this is the file I'm creating, and I'm opening here docker command demo. So this is the file. I'm saving this one like this. So now this is the path. So I'm going into here. I'm going to exit from this location. So I'm going to do docker container copy. The first one, copy source followed by destination. So the source is, if you want to copy from C colon demo 3, there is a folder name followed by docker. So let's go and get the path of that. So that is the path of the location. So now we're going to the docker container. So whenever you want to copy, so we need to type the container ID followed by the path. So we want to copy into this location. So usr into conf. So if you want to copy like this. So if you want to copy from local system, this is the source followed by container ID colon slash user local apache to conf. Now if we enter, now if we go to that container to check is it copied or not. So docker container exec-it container ID. The container ID is this one, then followed by bin bash. Now you'll see here, if we go to conf, now you can see docker cp text command. Now you can see the vim docker. Now you can see that. So this is the way to copy from local system. In the same way you can copy from container to local system as well. To fetch the logs, so it is a docker container logs. Then you can type the container ID. Now you can see the logs of that. So these are easy commands. So we already covered almost all the commands. So if you want more details, it is a very self-descriptive, and if you have any doubts, please pop me email so that I'm trying to elaborate in the upcoming sessions. Thank you.